back in lecture 13, we went over for loops. So for loops, remember that we use, for example, for something in some sequence, and in that sequence, what we do is do something. So a for loop typically looks something like this. So the idea is, if you want to make a for loop, hello. So if you want to make a for loop, what you do is, first you start with the unrolled version. So for example, if I want to do something several times, let's consider this. So if you want to do something to all elements of a list, for example, so let's have this example again. Define squares of evens, and I have some list over here. So what you want is to figure out what you actually want to do to each element of this list. So for example, you can have x is the first element, so L indexed at 0. Then what you do to L, or what you do to x here, is if it's even, you want the square of that number. So you have some answer here, and you're going to check if x is even. You're going to append the square of x to the end of the answer list over here. So append x squared. So this is for the first element. For the next element, what you would do is set x to the second element of the list. Then you're going to check if it's even. Then append its square to the end of the list. So same thing as the previous element of the sequence. And this will go on for all elements of your sequence. So for the next element and so on, until you reach the end of the list. So once you reach the end of the list, you just return your answer over here. So at each iteration, you're considering each of the elements of this list over here. So the idea is, if you have all of this, you can roll that back up into an actual for loop. So for example, what you're iterating over is the list here, L. So you can do for x in L. What this will do is, it's basically doing all of the steps over here when we're setting x to one of the elements of the list. So this and the other few lines over here. Okay, so for x and L, what we put inside here is the part that repeats. And here, yung part that repeats is just this part. So when it's even, we append the square to the end of answer over here. So actually, this already represents all of the iterations that we see over here. So we can remove all of that, and that leaves us with this. So we have a for loop, and inside each iteration, we do this to each element. So if we try to get this assertion here, we should hopefully have this pass. So there. That's how you would make a for loop. Try to make the unrolled version first, then roll it back up into a loop like this. Okay, so that was what we saw from last week. Let's continue. What if we have, instead of a single sequence, we have a sequence of sequences? So something like a grid over here. So let's see what happens here. We want to print a grid. So this grid will be a sequence of sequences. So whenever we call this print grid, then I just give it the numbers 1 to 6, 4, 5, 6, what I should get is each of these rows printed out in order. So how would I do this using a for loop? Well, since a grid is a sequence of rows, we can consider it one row at a time. So for example, we can have the current row that we're considering is grid at 0. Then if we want to print that row, well, what we could do is just print, then splat the row into the print function. So something like this. And we can do this again and again for the remaining rows. So for the second row, we just set row to the second row, then print it out like this. And similarly for the rest of the rows here. And this will go on until you go over all rows of the grid. Okay. Okay, so again, if you want to print out all of the rows, you go over each row first, then you print out all of the elements in that row. That's basically what we're doing here. So you're just going to do this for all of the rows. So this will go on until you finish all of the rows of the grid. And if we want to write this using a for loop, since we're iterating over each row of this grid over here, this is just for row in grid. That's what sets row to each of the indices of grid over here. And inside, we're just going to put the part that repeats. So print out the row. So if we try to run this, we should now have each of the rows printed out like this. Okay? So that's how it works for 2D grids. You still use the same idea. Okay, so let's have some other examples here. So here, instead of just printing out each of the elements themselves, we also want to print out their indices. So what we want is this 3 is at index 0. So we print out 0 and 3. Yung 1 is at index 1. So we print out 1 and 1 for that. Okay, so same thing for the rest of the elements over here. Okay, so how do we actually do something like this? So if we want print with indices of a sequence, then if we were to print out yung elements themselves without the indices first, how you would do that is something like set it to each element of the sequence, then just print it out like this. So x is sequence 1, print x, and so on and so forth. This will go on until you finish iterating over the sequence. So what if you now want to print out the index as well? So this 0, this 1, this 0, this 2, and this 3. Well, since you want to print something else, you also need to keep track of that. So I is 0, for example. Then here, instead of just printing x, you're going to print out I as well as x. Then what you're going to do here is increment I by 1. So after each iteration, you increase the I over here by 1. So print I and x again, then increment I by 1, and same thing for this iteration, I plus equals 1. So each of these is now a single iteration of the unrolled version. So if we were to actually turn this into a for loop, what we can do is, since yung sequence, this is what we're iterating over, we can have for x in sequence that takes care of all of these lines. We just print out I and x, then increment I at the end. So this is the part that keeps repeating. So we put that inside the for loop. So if we try to do this for 3141, print with indices 3141, what we should see is hopefully the same output. So 0 and 3, 1 and 1, 2 and 4, and 3 and 1. So this is one way to do it. Another way is, if you want to base everything off of yung index already, what you can also do is for I in range, then you want to iterate over all elements of the sequence. So this can be range length of sequence. Then here, what you're going to do is print out the index as well as the element at that index. Here, that would be sequence at I. So that's another way to do this. Instead of explicitly writing out the index here and updating it, you already use the index in the for loop itself. So that's another way to do this. If we run this again, we will get back the same result. Okay? So that's how you do that. Okay. So what if this time we want to look at several elements at a time? So here it's asking how many pairs of consecutive letters. So for example, the M and the I here, then yung I and S, yung S and S, and so on. How many of these pairs are equal? So here, there are 3 of them, yung double S and yung double P. So 2 double S's and the single double P over here. So we basically want to count the number of those inside this string. So for that, if you want to count the number of equal consecutive characters, and we have some string, then since you want to consider pairs at a time, what we can do here is, let's start first with I is equal to 0. What we want to check is whether S indexed at I and s indexed at I plus 1, we want to check whether these two are equal. So if they're equal, then we increment the answer by 1. So we have some initial answer here that we're going to return at the end. And in between, this is what we're doing. We're checking if each consecutive pair of characters is the same. Okay, so here we can do I is equal to 1. Then we can check this again. Then so on and so forth. I is equal to 2. Then check this property again until you finish iterating over the string. So here, since what we're iterating over is a bunch of numbers, 0 until the end here, one thing we can try is, since I is the variable, we can have for I in range length of s again. Then here, we put the part that repeats. So this part over here. So we can remove all of that. We're left with this implementation here. So if we test this against this particular case, the answer we should get should be 3. So if we try running this, you'll see that we get an index error. Why are we getting an index error here? So it's saying that here we have an index that's out of range. If we think about the indices for s here, that would be 0, 1, 2, and so on until length of s minus 1. These are the valid non-negative indices for s. If we look at what our for loop is doing over here, yung first iteration checks 0 and 1, yung second iteration checks 1 and 2, then so on and so forth. For the last iteration, what it's going to check is length of s minus 1. Then yung I plus 1 is going to be whatever this plus 1 is. And that plus 1 is going to be length of s. Yung length of s is not a valid index. So that's out of bounds of this range here, which is why we're getting this index error over here. This length of s is out of range. So to fix this, what we have to do is, well, make the for loop not access this index. So instead of ending before length of s, we end before length of s minus 1. So if we do that, hopefully, we now get the right answer. So there are no assertion errors here, which means that this assertion passes. So that's what happens if you consider multiple elements at once. You have to be careful about where you actually end the for loop over here. Okay? So let's go over a few more. Here we now have a sequence of pairs. So define all powers. Then we have a bunch of pairs. And what we basically want is each of the first elements raised to the power of the second elements. So if we run this, what we should get is 116 and 27. So that's 1 raised to 5, 2 raised to 4, and 3 raised to 3. Okay, we want to build up a list. So let's say answer is an empty list. And we return the answer at the end. Let's consider what's happening to each of the pairs over here. So for the first pair, we have the base as well as the exponent. So that's pairs of 0. And what we want is to append yung base raised to the exponent to the end of the answer over here. And that's what happens for each iteration here. So we do that for the second pair, for the third pair, and so on. So if we want to roll all of this back up, what we do is for BME in pairs, what we're going to do is put each of these, the part that repeats, inside the for loop. So there. If you notice here, one important thing to note is you can do destructuring inside a for loop. So this part over here. Instead of doing something like for pair in pairs, then you're going to do the destructuring in this part. B and E is equal to pair. Instead of writing it like this, you can directly destructure in the for loop itself. Okay? So by doing that, if we now try to run this, we should now be good. So that's how you handle a sequence of tuples. So you can also destructure each pair here in a sequence. Okay. So again, just like most of the previous examples, you could also use a comprehension for this. So this is just b raised to e for b and e in pairs. Simple as that. But we're demonstrating it using a for loop, since depending on how complex your for loop can get, it might be more helpful or more useful to use a for loop instead of just a comprehension like this. But yeah, this is also doable using a comprehension. Alright, so what else? This time, let's try this. So we have a word again, and we want the vowels, so A, E, I, O, U. But this time, we want the vowels in reverse. So we start with this A, with this I, with this, then the O, then the two A's at the front here. So we want all vowels in reverse. Okay. So there are two ways to go about this. The first one is, if we want it in reverse, we can directly reverse the string itself first, or we can iterate over the string in reverse. So it's either the sequence that we're reversing or the iteration that we're reversing. Reverse either the sequence or the iteration. Let's actually try both of those. So if we were to reverse the sequence, what this would look like is, let's reverse S first. So S is now its own reverse. Then we just iterate over each character again. So C is the first element. If C is a vowel, this vowel, then C, then what we do here is, let's say we start with an empty string. What we can do is add that vowel to the answer. So answer plus equals the vowel. So for this, we can just implement it like this. To check if a character is a vowel, what we can do is check if C is inside A, E, I, O, U. So there. This is for the first iteration. For the next few iterations, we can have S1, S2, and so on. So if we wanted to roll all of this into a for loop, what we can have is for C and S, we put this part over here. So if C is a vowel, we add that to the end of the answer. So there. If we try this assertion now, this is the assertion. If we try running this should now be, what does this return? I forgot to return here. So return the answer. If I run this now, this should now be good. So this is if we reverse the sequence itself, or S, yung string. What if we try to reverse the iteration instead? So instead of reversing the string itself, let's try reversing yung iteration. So normally, you would iterate over a string using the indices 0, 1, 2, all the way until length of S minus 1. So if you were to iterate over this in reverse instead, what you can do is C is S at length of S minus 1. So this is the end of the string. Then here, what you do is, if C is a vowel, this vowel, then you add that to the end of the answer. So that's one iteration. Yung second iteration is this minus 1. So minus 1 or minus 2. And you do the same thing. Check if it's a vowel. And you just keep doing this. So what you can do here is foresee in the part that's changing is the index over here. You start at length of s minus 1 and you end before yung last iteration here is going to be the first character. So s at 0. So you want to end at 0. So you want to end before negative 1. When yung step size is minus 1. So you're stepping from length of s minus 1 to 0 in reverse. So if we have this, what we put here is the part that repeats. And there. We now have this for loop. So let's now comment out all of this, or remove that. Here, this is an index, and the character is going to be s at that index. So we're now iterating over the characters like this. So if we run this one, it should also work. So you can choose to either iterate over the reverse of the string or the string itself, but your iteration is in reverse. Okay. Or alternatively, you could also iterate over it normally, then just reverse the result at the end. This would also work. Okay, so again, nothing is stopping you from doing wishful thinking, even for imperative problems. So here, we use this vowel in a separate function like this. Okay. So here, the implementation of is vowel is like this. If you notice here, there's a all caps vowels over here. This is just the set of all vowels here. So when we have a variable in all caps, what we usually mean by that is that this is a global constant. So it's global since it's not inside a function, and it's a constant. We don't want its value to change. So this will always refer to the same frozen set. So again, a global constant should be in all caps. So vowels is A, E, I, O, U. Then we can refer to that here as the same variable. So something like this. Okay, that's a global constant. Alright, so there's this solution here that explicitly writes out the character plus the result. So what this is doing is it starts with an empty string, just like us. And what it's doing here is instead of doing answer is answer plus C, it's doing answer is C plus answer. And your iteration is not in reverse. If you do that, what will happen is this will give you the vowels in reverse, since if we go over all of the characters, then each time we're adding it to the front. Let's say we have the same example. Let's say we have this string. If we iterate over each of the characters here in order, so starting with this A, we will have the empty string becomes A plus that empty string, which means this will now become A. For the next A over here, what you'll have is A will turn into A plus A, and that's just double A. For the next vowel, yung O, what will happen here is O becomes O plus the current string, so that's OAA, and so on. This will, since you're adding it like this, character first before the answer, you will get the vowels in reverse like this. So that's another way to solve this problem here. So this is actually slower than the counterpart of doing it like this, since strings are immutable. So whenever we add strings compared to the earlier solution here, joining them at the end, this is slower because strings are immutable. And just like tuples, whenever you add strings, you make a new string every time. So if you try a large input like this, for example, let's say we have our solution here, then we try to run it on this very long string. So this is scientific times 10 raised to 5. So this is a very long string. And if we try to run it here, this will be relatively fast since may optimization si Python for stuff like this. If we try answer is answer plus C, this will still be relatively fast. But if we compare this with the other one, let's say we have this other solution. We have a list and we're adding stuff to that list. We're going to do rest.append, then C. Then what we do here is return, just join all of the characters inside the result here. So if we run it for this particular string, so it's also going to be very fast. So let me try making it a bit fast, a bit larger. What will happen if I try to get that? So here, it's taking around 1.5 seconds for this first one. The one where you use a list and join it at the end. For the second one, let's say we do the normal looping part. For I in range length of S, then here, if C is S at I, if C is a vowel, what we'll do is answer is C plus answer. Then we just return answer at the end. If we try running this one, we'll see that this takes significantly longer than the first one. So just be careful whenever you're adding strings together, since just like tuples, this will always make a new copy at each iteration. Okay? So we'll go back to this in one of the later lectures. But for now, whenever you want to build a string, just like what we did here, try to start with a list first, then join all of the results at the end. That's a lot faster than adding stuff like this. Okay? Alright. So what else? Here we now have two different sequences and we now want to get their Cartesian product. Okay, so here we have two sequences. Let's get rid of this part. Oh, okay. So here I want all pairs among two different sequences here. Sequence 1 and sequence 2. So for this, what I want is to pair up each element here with the first element that makes up the first three elements in this result here. Then same thing with the number 2 over here. We want to pair that up with each of 3, 4, and 5. Okay, so how do we do that? So let's start first with the first element of sequence 1. So x is sequence 1 indexed at 0. And what you want to do here is you want to pair this up with each element of sequence 2. So what's essentially happening here is you have sequence 2 at 0. Then if we have some answer here, your first iteration is going to be append x and y, the pair x and y to answer, then instead of updating x, what you update is y instead. So y is sequence 2, index that 1, and you're going to do the same thing, append x and y. And you're going to do this until you reach the end of sequence 2. So end of sequence 2. Once you do that, you now have the first element paired up with all elements of the second sequence. So for this example, that would be something like the first row over here. Yung first element ng first sequence, yung 1, it's now paired up with each element of the second sequence. So 3, 4, and 5. But aside from that, we also want all of the other pairs. So we now have to update x again. So x is sequence 1, but now we're indexing that at 1, not 0. And after that, we want to pair that up with each of the elements of sequence 2. So we're going to literally write out this again. Answer.append x and y. Y is equal to sequence 2, then 1, then answer.append x, y again. And you're going to do this all again until you reach the end of sequence 2. And after that, you're going to update x again to the next element of the first sequence, then do all of this part again. And you'll do this until you reach the end of sequence 1. Then return the answer at the end here. So now what you're seeing here is inside each iteration, there are a bunch of additional iterations. So what's happening here, if we're going to roll back up into a for loop, we have x that's iterating over sequence 1. Then inside here, the part that's repeating is this part over here. So these lines are what happened at each iteration. So our function looks like this. Now if you notice here, this time, inside, we're iterating over each element of sequence 2. So y is sequence 2 at 0, at 1, then so on. So if you think about it, if we roll this loop, or these iterations into their own loop, you would have a for loop inside a for loop. So for y in sequence 2, then the part that repeats is now this. So now, we can remove this part, since this is now represented by the for loop. And what we end up with is something very compact. So for each x in sequence 1, for each y in sequence 2, we append the pair x and y. So this is now a nested for loop. We have a for loop inside another for loop. So if we try printing out all of those pairs, so for pair in all pairs, let's try 1, 2, and 3, 4, 5. Let's try printing out those pairs. So here, if I run this, we should now get all pairs between the first sequence, the 1 and 2, as well as yung second sequence, 3, 4, 5. So this is how you make a nested for loop. Okay? You do this if you want to iterate over more than one sequence. Okay? Alright. So again, just like with comprehensions, you could write this as just return xy for x in sequence 1, for y in sequence 2. These two are essentially the same thing. Okay? So that's a nested for loop. So as you probably noticed by now, since this looks pretty similar to, if I write the comprehension again, xy for x in sequence 1, for y in sequence 2. If you look at this closely enough, this looks oddly similar to this for loop over here. What you're basically switching around is this goes here, but yung result goes inside the for loop at the bottom here. So they're very similar, and how they're actually similar is something we'll go over in one of the later lectures. Okay, so that's for loops. So these are some relatively simple for loops. So again, the idea is try to keep track of what happens in each iteration. So start with the unrolled version, then roll all of that back up into these actual for loops over here. Okay, so there are a lot of practice problems in the practice sets for this, so kindly go over them. Okay, so another note, in the first hope, we mainly went over comprehension and recursion. Yung second hope is mainly going to be about loops. So if in the first hope, you're only allowed to do this, for the second hope, it's only going to be loops and the other stuff we'll discuss later. So make sure to read the restrictions part to know whether you have to do comprehension or recursion, or loops and the next lecture. Okay, so make sure you actually read the problem restrictions. Okay, so that's going to be it for loops. Are there any questions for this? No questions? Alright.